Hi, everyone. I just wanted to welcome you to this webinar and how to gain faster ATO and approvals on cloud native applications. So we're going to go ahead and get started here. My name is Michael Tillman. I am the Principal Solution Architect here at Mirantis. And I've been with Mirantis for quite a long time, and I've done multiple webinars and talks and around different subjects from Kubernetes, OpenStack, infrastructure, etc. I've spoken at Open Infra, as well as KubeCon. So yeah, I've got a little bit of a experience doing this, and so yeah. So the agenda for today is going to be, as you can see on the screen, cloud native applications, what they are, how you can get them, etc. And then the many layers of the challenges that will be out there. And then I'm going to talk about the DISA STIG, and as well as FedRAMP certifications, the certified stack, and then partnering in order to achieve your ATO much quicker. How do you gain faster ATOs and approvals on cloud native applications? So first of all, cloud native applications can deliver securely, resilience, speed, and agility across the public sector. And those entitlements need and meet demanding mission critical goals and timetables. But innovation for the public sector can be slow, it can be risky, and more importantly, it can be very expensive without a STIG certification on your platform. So strongly supported platforms are absolutely the ground base for your efforts. So what exactly are the cloud native applications? So cloud native technologies bring a huge organic benefit to the public sector. And here, just for example, there are open source container orchestration platforms such as Kubernetes, Swarm, just to name two, but they provide built-in automation and standardization for your tools, for updating your applications, keeping them available, and scaling them to meet your organization's demands. Security, high availability, and guaranteed performance are easier and much cheaper to achieve with these technologies than any other prior generation of solutions. So the containerized software development and modern application design patterns allow your developers to build better, more secure applications faster, and it allows you to evolve them more quickly. And what that gives you, it gives you a powerful complement to leverage and extending the container orchestration capabilities that are native to both Swarm and Kubernetes. So overall, these types of technologies enable massive agility. And in delivering software, putting it where it's needed, so basically in data centers, in the cloud, network edge, small devices, IoT, and the likes, are just, they allow you to keep healthy and secure while minimizing the operational labor, the resource utilization, and of course, the associated costs. The cloud native tech stack is very complicated though, and migrating to a container-driven solution and infrastructure poses a very particular set of challenges to the public sector and to service providers as well. There are also other verticals that are experiencing these types of pains: software makers, consultants, and anyone that really wants to deliver value to the public sector vertical. Let me talk just real quickly about the many layers of the challenges and what they are and what they mean to organizations, especially within the public sector. So how do you make sense of the cloud native landscape? There's a lot of things going on. There's over 150 different applications that are CNCF certified. There are over 170,000 some odd different individual contributors that are doing things within the space, and so it's a very complex very challenging road to navigate. And I'm sure that everyone has seen this or some other type of busy screen that you know, that's kind of going around in the world right now. But this just drives home the point that there are a lot of things going on within the CNCF world. And so basically there are three categories of challenges that I'd like to talk about, and they need to be addressed so you can understand what the full stack of the public sector software solutions that need to be approved, that need to be deployed, and that need to be operated over time to support your critical mission objectives. So the cloud native platforms and all of the supporting infrastructure must be engineered and hardened in very specific ways to comply with the platform specific as well as the general baselines that the public sector security and data protection requirements are regulated by. So one of those places is DISA. That's the Defense Information Systems Agency, and they are in collaboration with FedRAMP. That's the Federal Risk and Automation Management Program. The cloud native software developers, they have to build on and potentially extend what the platform intrinsic security systems are. So they deliver these solutions and they must meet a very specific mission or use case relevant security requirements. And they need to achieve an ATO, which is authorization to operate, from the DoD or DoD adjacent approvers. And so, and you must comply with the FedRAMP low, medium, high security. So these are the baselines that are required by the GSA, federal and state governments. Other agencies such as civilian contracting organizations and other potential customers, those are just some of the challenges that organizations such as yours are going to be facing or have already faced. The other is continuous monitoring and oversight of your software and infrastructure. It must be proven as part of your solution. So if you have something along the lines of like a SaaS offering, this has to be, it has to be secure. So to ensure that security and other requirements that they will continuously be met are as part of the solution when they're operated, updated, and improved over time. So the process of achieving these approvals is very complex and it's very complicated, and many different paths exist for you to be able to go through this system. And depending upon the solution architecture, the use case, your end user organization, and basically where you sit within the federal space, it takes a long process in order to store and deliver many of these variables. So for example, for a DoD solution, there's a two-phase process that's normally followed, where you first achieve the provisional authorization under DISA and FedRAMP scrutiny, which is done with the DoD collaborator. And then, of course, there is the ATO, and that's granted by the DoD mission owner. So for implementations of the solution, many of them are pursued via a second phase or reviewed by the DoD component authorization officials, who closely scrutinize specifics and how the implementations will work, how it will be used, and how the data will be managed. So basically, the solution provider is responsible for all of this. And the people that are building the solution, documenting it for the approval process, achieving the PATO, adapting it to meet the additional ATO requirements, and then potentially for continuous monitoring and support. This is technically demanding and very time consuming. And most organizations undertaking it employ expert and usually costly consultants to advise and smooth the process over as they go through each of these points. So gaining ATO and other authorizations represent major investments of time, talent, money, and resources and dominate the solution lifecycle from end to end. For mission owners, they represent potential hard barriers that can delay reaching your mission critical goals. They're costly from a technical standpoint to make your goals achievable, and can delay adoption of beneficial new technologies that have not yet necessarily been approved. So now let me talk just quickly about what the solution to all of these problems are, and basically that's the DISA STIG. And the way that you get there is starting from a known good point. So first off, you need to choose a platform. For cloud native software, that means either Kubernetes in some form or Swarm. The bare metal container runtimes alone or clustered via a simpler orchestration like Swarm is a very critical basic step for gaining approvals on a complete cloud native solution. When you're tasked with delivering an application that must gain approvals in a very short or reasonable amount of time, it makes sense to work with platforms that are known to be good. And what do I mean by good? That means that they've already aligned with the approval requirements, or more commonly known as the alignment with reasonable effort. And where that platform provider is known to be knowledgeable and willing to work with customers to successfully achieve full solution approvals and implementation of those specific ATOs. So how do you know a candidate platform is good? One important piece of evidence is the current STIG. That's the Security Technical Implementation Guide, and this is issued from DISA, the Defense Information System Agency. So a STIG for a cloud native platform or platform component comprising of basically a punch list and methods for configuring and hardening those specific products to meet the security requirements and standards that are set forth by the DoD. The different divisions of the federal government, state governments, aligned governments, contractors within those governments, they usually contribute to that supposed punch list that's being administered by the DoD. But basically, the STIG ensures that the necessary configurations to meet those DISA requirements are already identified, and they're defined, and they're approved through a chain of trusted entities culminating in the DISA itself. So basically, in simpler terms, the product has to possess baked-in characteristics and features that are required as preconditions for reaching the security states required by the DoD and DISA. The product can be configured to achieve these states, and that this work has actually been done, tested according to those requirements, and certified as correct. So by implication, a current STIG also strongly suggests that this is repeatable in practice, scalable, and can be generalized across implementations. So what do I mean by that? By reference to the STIG, the platform and the providers can automate the configuration and the deployment to deliver these implementations of the platform in a range of very practical configurations. So different scales, different number of nodes, and so on. So all of which will meet the DISA security requirements. So it doesn't matter how many different ways that you put the nodes, how many different nodes, and the amount of nodes that you put in, those will all meet the DISA security requirements. The provider can potentially do this across a range of target physical or virtual infrastructures. So what do I mean by that? I mean that the servers can be in an agency data center or on an approved cloud, on small devices at the network edge, or in the battlefield without undermining the product or the host infrastructure desired security state. What does this mean? It means that the platform or the component not only provides the required security in a proven way, but it's sufficiently able to operate. It enables you to deliver a complete solution that is trustworthy, agile, easy to install, and manageable, flexible, and cost optimizable. So let me now talk just quickly about the secure stack. And this is, again, the problem solution, the portion of the solution that we're addressing the issue that we've decided in. So the secure stack is it has to be installed as we just previously discussed. So any weak link can undermine the security of a deeply tuned cloud, and so when it makes sense to minimize the unknown paths of any platform under any type of attack on that particular stack, then you can control and mitigate or absolutely turn away any type of attack that's unwanted. So one way to do this with platforms is to acquire a complete pre-integrated solution, all of whose components are covered by the current DISA STIG. So for example, a Kubernetes platform can earn a STIG, which covers many aspects of how the orchestrator seeks to encrypt data or to manage access control. Its container engine can also earn a STIG, focused more closely on the built-in encryption facilities, and these also can earn complementary certifications like FIPS 140-2 or FIPS 140-3. What is FIPS? And basically that is the Federal Information Processing Standards. And that's mostly developed by NIST, and it complies with the Federal Information Security Management. And those are all encryption modules. And they provide the hardening guidance against container escapes and the other security concerns. While both of these components are integrated by a single provider into a complete solution, the resulting platform is likely to be more optimal than when the components are acquired by different sources, by different solution providers and integrated. So among those benefits, providers can reasonably expect that a fully DISA certified STIG cloud native platform is going to have basically these types of components and characteristics. So the provider has basically worked to optimize the security of the entire platform based on their own and industry best practices, as well as the STIG certifications. The provider has built tooling to enable flexible, rapid deployment of the whole platform in its STIG configuration, versus leaving any part of this up to the individual to build or validate. Key quality of life features have been deployed and built into the product to make it more flexible and usable to the solution providers or to the end users and customers. These might be something along the lines of the built-in ability to create a secure end-to-end container software supply chain. It might also include the ability to deploy Kubernetes worker nodes or on Linux or Windows hosts. It also includes the ability to select multiple orchestration nodes on each worker basis. So basically what that means is you have the ability to easily define a worker node that's using Kubernetes, or alternatively using the Docker Swarm orchestration. In addition to this, there are valuable pre-integrated platforms such as Swarm and the clustering ability of the container engines, but they may be covered under existing DISA STIGs, further extending the protect surface provided by the platform as a whole. So one of the last points that I'd like to make about this is the ability to update all parts of the platform. So going forward, you will be tested and validated by the provider, and this is important to maintaining security. So patches against recently discovered exploits and ensuring that the continued graceful functioning of the entire platform. So where are you right now? And where are you along this containerization journey? And I think what I'd like to say here is that the organizational performance, as it goes up, your containerization maturity continues to evolve. And so whether you're at the lower left-hand corner here with no containerization, or if you're up in the upper right-hand corner, the optimization of those containers, there is always some place that we can assist you and partner with you to get yourself to the faster ATO. And I'm going the wrong way, sorry. So what is it that we offer that will assist you and grow your organization? And that is the container offerings that we not only have, but we're completely ready to go with these. And the value of this cloud native platform is fully covered by the DISA STIG that lies in reducing the unknowns, right? And so from starting from a known good state so that you can engineer a complete solution more rapidly with firm assurances that the core platform layer requirements are met and that the platform provides the features you need to build on securely. And so the Mirantis Secure Registry is a secure registry for all of your images. Lens Kubernetes IDE, the Lens App IQ, Lagoon, Mirantis Kubernetes Engine, as well as K8s, and the Mirantis Container Runtime. So choosing the right platform with the right deployment automation and configuration flexibility, those need to meet the requirements on many different underlying infrastructures. And this gives you a valuable ability to reach scale and abstract your solution from the infrastructure mechanisms. It makes your solution viable and approvable in a great range of environments and gives you and your customers the opportunities to cost optimize around your operations, your staffing, and your infrastructure. So a consistent cloud experience is something that we provide here at Mirantis. And whether you're a developer or whether you're an operator, you can rest assured that because of the DISA STIG, the Mirantis Container Cloud will give you self-service clustered, apps, and DevOps portability, one source for a full stack LCM, and centralized insights and management. So the Mirantis Kubernetes Engine is a production-ready, complete CNCF-validated Kubernetes platform with pre-integrated Nginx ingress, Calico container networking, and a resilient integrated block, file, and object store provided using the Mirantis optimized Ceph. MKE, Mirantis Kubernetes Engine, can run on any validated Intel or AMD architecture hosts, physical or virtual, with manager nodes on virtually any validated Linux and worker nodes on virtually any Linux or Windows Server 2012 or later. MKE provides a web UI enabling basic cluster operations, review of metrics, and simplifying updates. It also provides a fully standard Kubernetes API for management by CLI or software for greater speed. Via an operation and software deployment-oriented Kubernetes IDE like Lens, and we're in the final stages of approving and being approved a STIG for MKE entirely on Kubernetes. MCR, which is the Mirantis Container Runtime, is a highly secure container runtime compliant with the Kubernetes Standard Container Runtime Interface, CRI. MCR is deployed by default as the container runtime used by MKE, the Mirantis Kubernetes Engine. It can also run standalone on virtually any Linux or Windows server, and the MCR nodes can easily be joined in a Swarm cluster as well, providing a simple, minimalistic clustering system with a minimized footprint and attack surface for customers who don't require Kubernetes sophistication. When the Mirantis container runtime is deployed as part of a Mirantis Kubernetes Engine cluster, each worker node can be set to use Kubernetes or Swarm orchestration. Mirantis Container Runtime provides built-in FIPS 140-2 and FIPS 140-3 encryption modules, eliminating the need for your solutions to derive FIPS compliance encryption from the underlying host operating system. MCR includes swarm mode orchestration, and it's covered by its own DISA STIG. The MKE minimalistic Linux OS is a single source curated container stack, and Mirantis now provides the Mirantis Kubernetes Engine Kubernetes stack, or the Mirantis Container Runtime Container Engine. It's a productized configuration delivered on a minimalistic version of Rail-compatible OS tree-based Rocky Linux. MKE configurations deploy on bare metal or virtual machines from a single image, assembled and validated in every detail by Mirantis, and available from Mirantis Online or in file form on media for air-gapped installations. Update to Mirantis Kubernetes Engine deployments can rapidly be performed using OS tree from comprehensive image releases, providing a curated, tested, and rollback update capabilities to minimize the downtime and security concerns. Mirantis delivers Rocky Linux with Mirantis Kubernetes Engine, hardened by default and with critical directories write protected. Mirantis Kubernetes Engine will be covered by the DISA STIG for MKE on issuance. The Mirantis Container Cloud, which is here, is also a Mirantis product that is part of the hybrid cloud, ready to deploy Kubernetes and the operations and lifestyle management system. It's self-built with the Mirantis Kubernetes Engine cluster. Mirantis Container Cloud provides simple web wizards for deploying, scaling, and updating clusters on one or on multiple infrastructures. So on-premise, data centers, and approved GovCloud, and making these securely accessible to operators and developers through a single pane of glass via a provided RBAC or access control web UI, and by integrating with existing IAM systems. Mirantis Container Cloud deploys these clusters complete with telemetry for operational metrics, and they're aggregated by Mirantis Container Cloud using a Mirantis built and validated solution called Stacklight. And a source of, these are all, Stacklight is a suite of open source graphics dashboards that make it easy for operators and developers to view metrics and troubleshoot across many clusters and many different infrastructures. It can also target clusters on bare metal servers, VMware private clouds, OpenStack clouds, as well as the different types of platforms like AWS GovCloud and Azure GovCloud. The full stack, fully operational STIG is a system of ideally flexible platforms for supporting mission solutions on the widest range of approved environments, establishing a strong and validated secure fashion and foundation, and providing efficient delivery and operations automation, while also remaining compliant with CNCF and related open source standards. It enables you as solution providers and developers to leverage a trustworthy cloud underneath that minimizes operations and focuses on the solution. So just again, to go over the different Mirantis products, from a application delivery standpoint, we have Lens Apps and Amaze.io. From a Kubernetes IDE standpoint, we have Lens. From a multi-cluster management, we have the Mirantis Container Cloud, as well as Cosmotron. The container registry is the Mirantis Container Registry. The Kubernetes distribution is the Mirantis Kubernetes Engine, as well as K8s. The container runtime is the Mirantis Container Runtime. The operating system is the Mirantis Rocky Linux, and the infrastructure as code is Mirantis OpenStack for Kubernetes. In practical sense, gaining approval means working closely with Mirantis engineers to ensure full understanding of the specific requirements your solution must meet, then executing systematically. In some situations, this may require adjustments to how the Mirantis products work, adjustments to the Mirantis tooling, or other technical changes. But in general, these changes are not extensive and can happen quickly. Mirantis also offers a host of highly automated, basically productized, to help cloud transformations happen faster and on a more predictable timeline. An example of this is the application migration and modernization platform, a tool that securely works in an air-gapped or other isolated environments, automatically evaluating applications running in legacy cloud or in data center environments, ranking them by complexity and dependencies, planning a modernization and migration strategy, and then executing. Automation and production of these artifacts, such as your Docker files, to speed up the software refactoring and repackaging for running in containers on platforms and orchestration like Kubernetes and Swarm. So modern application delivery depends on cloud native technologies like container orchestration for speed and flexibility. Choosing a fully STIG baseline cloud native platform eliminates the unknowns and provides an optimal foundation for software solutions that leverage automation and manage service to speed the delivery, lower your operating costs, reduce risks, and enable your users to focus on applications versus having to focus on platforms and infrastructure. The Mirantis Containers as a Service platform is the most secure container platform in the industry. Its Mirantis Kubernetes Engine and Mirantis Container Runtime are covered by the current DISA STIGs. Mirantis provides flexible, automated deployment, scaling, operations, observability, and lifecycle management across hybrid infrastructures with its Mirantis Container Cloud Automation Suite. And Mirantis is structured to work as an attentive, committed partner in achieving ATO efficiently and serving these critical DoD and public sector missions. So thank you very much. And if you have comments, please feel free to email me at any time at mtillman@mirantis.com. And thank you very much for attending this webinar.